Wireless communication is not really something new. People always wanted to communicate in, let's say, local area networks. We can use our voice for wireless communication. In wider area networks, we can use light. We can use flags or smoke signals or even something like an optical telegraph. Here, we are more interested in something that uses electromagnetic waves. So almost 200 years ago, Faraday already demonstrated electromagnetic induction. James Clerk Maxwell came up with theory of electromagnetic fields, but many people still believed, no, this cannot be true. You need something like a medium to transmit these kind of waves of fields. And this is how also the term ether was coined. So there must be an ether somewhere between the earth and the sun, because we see sunlight, actually electromagnetic waves. But today we know, no, we don't need this. Heinrich Hertz finally demonstrated with an experiment the wave character of electrical transmission through space. That was in 1886. Actually, in the same lecture hall, I gave the first mobile communication lecture in Karlsruhe in Germany. But the real history of wireless communication starts with Marconi, with his first demonstration of wireless telegraphy. It was fully digital, but he needed really huge antennas, high transmission power, more than 200 kilowatts. Think of today's mobile phones. We're talking about milliwatts, 200 kilowatts. That's quite a lot. Already in 1907, we had commercial transatlantic connections with huge base stations, 100-meter high antennas. We had wireless voice transmission between New York and San Francisco. We had Marconi discovering short waves. Well, short waves reflection at the ionosphere. We had way smaller senders and receivers due to the invention of the vacuum tube by de Forest and von Lieben. And already almost 100 years ago, we had a train phone along the line between Hamburg and Berlin. So we had wires parallel to the railroad track. So actually this is wireless between these wires and the train. The history continued with TV broadcast trials, with already color TV, 28. Armstrong invented the frequency modulation. I will come back to this modulations, what this is, later on. After World War II, in Germany, we started with the A, B nets and then the C network. Those were analog wireless communication systems. And the problem at these times was you had to know the location of the mobile station. So we already had something like 13,000 customers, at least in Germany, end of the 70s. At almost the same time, the Scandinavian countries invented the northern mobile telephony at 450 megahertz. And then the real breakthrough started in the early 80s with the start of the GSM specification. GSM, a pan-European project for a real full digital mobile telephone system, including what we use today, roaming. That means you can use your device in many different countries. 83, start of the American advanced mobile phone system, which is still an analog system. Then we had new standards for cordless telephones. History continues. We had a still analog system, the C network in Germany, that was kept alive until 2000. We already had fax services, modems, emails, and a nice coverage of 98%, which is quite a lot. Also due to the fact that we used low frequencies around 450 megahertz. Then we had a pure digital cordless telephony standard, the DACT system operating at 1900 megahertz. What is special about DACT? Well, you can have up to several 10,000 uses per square kilometers. That's quite a lot. 92, so 10 years after work started, GSM started. GSM first came out in Germany at 900 megahertz, 124 channels, 2 operators. with automatic location of the user, automatic handover. How this works, I will tell you. It's a cellular system that allows roaming throughout Europe, and now it's used in more than 200 countries worldwide, so basically almost everywhere. And it already offered data transmission, 90.6 kilobit per second. Yes, I know this is not really much, but at least digital voice, fax service, 90.6 kilobit per second. Story continues with different GSM networks, already 98% coverage. And then the history starts with local area networks, wireless local area networks. Funny to see that was a standard called Hyperlan that already offered in the mid-90s 23.5 megabit per second. It was a complete failure, as well as wireless ATM, offering even higher data rates, not a commercial success. What was really successful was then the IEEE 802.11 standard. This is what we know today as the Wi-Fi networks, wireless local area networks, operating in the beginning at 2.4 gigahertz, offering 2 megabit per second. Then end of the 90s, we saw we need a new system. That was the start of the UMTS specification. Also a huge hype around satellite system. Iridium, as an example, wanted to offer mobile telephony around the globe. End of the 90s, we also had new wireless LAN system offering 11 megabit per second. Bluetooth started. Bluetooth, a new standard for small networks. And there was a decision made about the new worldwide global telecommunication systems. Well, we could not come up with a single standard, but rather with a family of standards. I will come back in chapter 4 to these systems. There were specialized protocols for mobile phones, kind of an internet for mobile phones. There were higher data rates for GSM, but there was also the problem of the internet bubbles. Well, we had the big crash in 2000. Iridium went bankrupt. Almost a year later, 3G systems started, first in Korea, Europe, Japan. And then we had many more things that happened. We had more and more new hotspot, start of UMTS, digital television. We had replacement of DSL starting, not really a big success. First Zigbee products, higher data rates, drafts for really many megabits per second for wireless local area networks using MIMO technology. I will explain this as well. So, and we had 2007 already 3.3 billion subscribers for mobile phones. Also some machines, not always people. And I would say 2008, we really had the internet available on mobile phones using standard browsers and decent data rates. So, for example, several megabits per second in a downlink. That's quite okay. So we had the first LTE tests. LTE, almost a 4G system. 2009, iPhone start, voice over IP, over wireless LAN. LTE was available then, 2010. We replaced the analog TV bands. And 2015, the system started to use voltage voice over LTE. Before that, we still had to use UMTS or GSM for voice. In 2020, basically all around the globe, you see 5G networks in operations. You always have years before the labs, but really in operation, well, this takes always time. So looking back at the history, well, this is not always a history of success. There are also many failures. Iridium, Hyperlan, WAP, WiMAX, these are just some examples. They were not really big success stories. So try to find out the reasons. Why did they fail, or at least they have very limited success? Also check out the new standards for mobile communications, because I gave you just a snapshot in the history. Go to 3GPP, IEEE, go to Zigbee, to Bluetooth, and look up what are the current data rates in the standard, then compare what is really offered. And you see there's always a time lag between standardization and what is actually offered. In the early days of GSM, the time lag was 10 years between start of standardization until the first products came out. Today, take it out for yourself, well, we are rather down to, well, now we can discuss, but it's more something like 3 to 4 years, which is pretty fast. But the market is really, really fast in this mobile communication context.